Welcome back. In video 2, we verified the gas and selected the correct connection. Now imagine that you are ready to move that cylinder to a patient. Before you take a step, ask two more questions. Is the cylinder secure and is the valve protected? A cylinder contains gas under high pressure, and if it falls and the valve or connection is damaged, gas can escape violently. Safe handling protects the equipment, everybody nearby, and the patient, depending on that supply. So start with secure. Keep the cylinder upright in an approved stand, holder, or cart, and during transport, secure it in an approved cart or holder. Never leave it loose or on the floor or on the bed or the stretcher. So next, separate full cylinders from empty cylinders according to the facility procedure. The cylinder can be present and still provide no useful supply. Then protect the valve. Use the protective cap on the large cylinders when appropriate during storage or movement. And never carry a cylinder by its valve or regulator. So keep oxygen equipment clean and free of oil or grease because oxygen does not burn by itself, but it does support combustion. Oil and grease and other unimproved materials can create a serious fire hazard. Match the cylinder with the correct regulator and connector. If the parts do not fit, stop and verify. Now, suppose you bring that cylinder to the bedside, attach the appropriate equipment, and turn on the flow, but no gas reaches the patient. You got to first trace the pathway in order from the source to the patient. First, check the source. Is there correct gas? Is there adequate cylinder or system pressure? Or is the cylinder valve open as required by the setup procedure? A correct connection cannot deliver gas from an empty or closed source. And second, we're going to check the connection. Is the correct regulator attached and seated properly? Is the connection tight? Is the required seal or washer intact? Listen for an obvious leak. Never use oil, grease, tape, or any kind of makeshift repair. And third, we're going to check the control components. So is that regulator functioning? Is the flow control device open and operating, or is an outlet obstructed? A problem with the entire pressure control or flow control can interrupt delivery. Fourth, follow the gas downstream. Is the tube disconnected or kinked? Is a humidifier or delivery device blocked? Is the patient interface connected and positioned correctly? If the patient depends on that gas, protect the patient first. Move to an approved backup and call for help according to facility procedures. Troubleshooting never outranks maintaining the patient's oxygen status. As simple as that. If a leak or equipment problem cannot be corrected safely, stop using the defective component. Remove it from service, identify it according to facility procedure, and report it. Do not experiment with the defective equipment at the bedside. Here are some cylinder factors to convert pressure into estimated gas volume. And we're going to skip over that for this video, and we will be working these problems in class, as well as here. We'll work this together. Okay, so now let's change scale. A portable cylinder stores oxygen as a compressed gas. A hospital central oxygen system may begin with a much larger supply of oxygen stored as cryogenic liquid, like we discussed in the last video. The first component on this slide is the reservoir. It holds extremely cold liquid oxygen in an insulated vessel. The near vacuum between the vessel walls slows heat transfer from the environment. Storing oxygen as a liquid allows a large amount of oxygen to fit into a much smaller space than that same amount of oxygen would occupy as a gas. So the liquid cannot simply enter the facility pipeline. It moves through a vaporizer where heat from the surrounding environment changes the liquid oxygen into gas oxygen. The gas then passes through pressure reduction equipment. This lowers the pressure to the facility's working pressure before the oxygen enters the pipeline. So the sequence is the reservoir, the vaporizer, and the pressure reduction. Stored as a liquid, converted to a gas, and reduce the pressure before distribution. Once the oxygen has become a gas at the correct working pressure, it enters a distribution chain. The primary supply provides the gas, pressurized control prepares it for distribution, and the central pipeline carries it through the facility. Zone distribution directs it into different areas, and authorized personnel can isolate a zone when required. So we never operate a zone valve unless you are authorized and the situation calls for it. The chain continues to a station outlet and then to the connected equipment. Each link has a job, and each can also be a location where delivery fails. So alarms help monitor the system. An alarm may signal abnormal pressure, a change from primary source to the reserve, or a supply problem. It requires a response. It is not proof that gas is reaching every patient normally. A reserve supply reduces risk, but it does not make failure impossible. It may replace a depleted primary source, but it cannot correct every downstream problem, such as a failed outlet or a disconnected tube or even a blocked device. When alarm sounds or delivery is interrupted, follow your facility's response plan and assess the patient, check the local supply and equipment, move to an approved backup if needed, and notify the appropriate team. Maintain care while the failure is located. So at the bedside, the central system chain ends at the station outlet. By the time gas reaches this wall outlet, it has already passed through the central pressure control and facility distribution. You met the two common connection families in video 2. A disconnection is gas specific and threaded. A quick connect system uses a gas specific keyed or shaped fitting. That exact quick connect design varies by facility, so you don't need to memorize every shape shown here on this slide. You do need to verify the outlet label and use the matching connector intended for that gas in the system. So we never use an improvised adapter just because a fitting appears close. So medical air follows the same source to patient safety logic, but its source is different from the oxygen system we just traced. A portable compressor provides compressed air at the point of use for selected respiratory equipment. A central medical air system uses facility compressors to filter dry and compress air before sending it through the pipeline. Central systems also use redundancy and alarms. So medical air is not oxygen and it is not a substitute for an oxygen source. Its oxygen concentration is approximately the same as room air. The outlet or hose still must be identified correctly, and the pressure must be adequate, and the pathway and the equipment must function. If a device using medical air stops working, use the same sequence: source, connection, control, components, then downstream tubing and device. Safe gas supply is a chain, not just a container. The correct gas supply must remain secure, protected, correctly connected, properly controlled, and available all the way to the patient. When delivery fails, trace that chain from source to patient and use approved backup when the patient needs one. In class, we will return to slides 15 and 16 to calculate how long a cylinder can provide a safe, usable supply. Then we will use the final class synthesis slide to decide whether a gas supply can safely reach the patient and what evidence supports that decision.